Okay, so let's start. Hello, everyone. Good morning, good afternoon, good evening, depending on where you are. Welcome to our second Networking Fridays of 2021. My name is Tania Li Chen, and I'm a project officer at INESCTEC Center, and I will be moderating today's session. Just to tell you a little bit about myself, I am a marine biologist. I did my early academic training in Portugal and then pursue a PhD degree in the US, working in genetic toxicology in marine mammals. I got to work with whales and dolphins chromosomes and participate in 6 expeditions, which was very exciting and unique. Then life took me to start and build a career off the bench, and I am now managing international and ocean-related science and technology projects within the Air Center, bringing together people from all around the Atlantic. But enough about me. Today's speaker is Susana Barbosa, who I met exactly a year ago in a workshop we organized in Cabo Verde on board a beautiful Navy school ship named Sagres within this project that she will talk about today. We spent the whole morning discussing biodiversity in Cabo Verde, and you can learn more about this event on the Air Center's website. So it is a great pleasure to introduce Susana to you. Susana is a senior researcher at INESCTEC in Portugal. She is a data scientist at the interface of data science, Earth observation, and robotics. She has a degree in astronomy, a master's degree in computational methods, and a PhD in surveying engineering on sea level change. Hence, her research is highly interdisciplinary, with a strong emphasis on the analysis of time series in the scope of climate and Earth system science. And her current research interests focus on novel environmental monitoring for the study of space, atmosphere, ocean interactions. And today she will tell us about the sail campaign on board Sagres. And very briefly, as Susana will go more into detail regarding this campaign, sail campaign aims at studying space-planet interactions at the global level. Then the data that is collected can be used in the prediction of thunderstorms and understanding electricity, and is also applied to study human health and air pollution, climate change, the effect of global warming, and access oceans health. So before going to the talk, I would like to remind you all that if you have a question, please write in the Q&A box and not in the chat box. So without further delay, Susana, the screen is yours.
So thank you, Tanya. Let me just share my screen. So can you see it?
Yes.
Okay. So I'm going to present. It's a pleasure to be here presenting the SAIL project. I've put here on the presentation the name of the core SAIL team, but it's actually this project got contributions from many different people. I think if I put all the names on a slide, it would not fit. And so I've tried to present you the project, and starting with how this all started. This all started by the, yes?
Sorry, can you put in the presentation mode?
It is in presentation mode. Better?
No, but I think it's
Is it better?
yes.
Okay.
Thank you.
So this all started with the opportunity that appeared when the Portuguese government decided to celebrate the 500 years of the first circumnavigation, which was made by a Portuguese, Fernando Magalhães. And in the scope of, there are several initiatives in the scope of the celebration. And one of them, it was decided by the Navy to do again a big trip, a big circumnavigation that would be made by our very emblematic ship, Sagres. So the idea would be not exactly to replicate the path, the journey of the first circumnavigation, but to do a big trip around the world that would take a little bit more than 1 year. And it came this, we wanted to take this opportunity to do some science on board. So we started to think what could be done to take advantage of this big trip that it's not so common. And we actually decided to focus on the marine boundary layer. So this is the layer, the interface between the ocean surface and the atmosphere. And so it's the part of the atmosphere that's directly influenced by the ocean below. And it's something that is very hard to observe directly. So while on land, we can think about putting some stations to observe the atmosphere. It's not so easy to do it over the ocean, of course. And it's not only hard to observe, it's extremely relevant for Earth's climate for several reasons. One of them is that it's a place where you have very intense fluxes of energy, of heat and moisture. And these fluxes really influence not only the local and regional climate, but even the global climate. And we need to quantify these fluxes better, and in situ observations are not so common. Another reason is that it's a region where you have low-lying clouds, these kind of flat clouds that you see here on the image. These low, thin clouds, stratiform clouds, are about 70% of the clouds are over the oceans. And it's still a bit difficult to represent them correctly in our climate models. And of course, this influences radiative balance. So it's an extremely important thing to understand for climate. And finally, it's very important because of aerosols. Of course, we all know that aerosols is still probably the component in climate models that is more tricky, because depending on the size and the distribution of aerosols, you can either absorb radiation or reflect it. So it's kind of tricky. But just to give you a visual impression of the importance of aerosols, I have here an image. You see mainland Portugal, the ocean, clouds over the ocean. And if you look carefully, you see some kind of lines that are actually, we call it ship tracks. These are clouds, or brighter part of the clouds, that are due to exhaust from the engines of the ships. So the aerosols that are released by the ships really affect locally those clouds. And I think this gives kind of a visual cue of the importance of aerosols, which of course influence all the cloud formation, microphysics process, the rainfall, etc. So this is extremely relevant area, the marine boundary layer, to study and to get data. And actually we decided to focus on one particular aspect, which is the electric field, that the electrical properties of the atmosphere, because it's extremely relevant for global climate. And it's also one of those things that is actually easier or has advantage to be observed over the ocean. And I will go a bit slowly into these in the next slides. So the motivation, actually, the idea, the story is we were on a meeting and my boss actually told us, well, we should do something on Sagres, some science, what could it be? And actually, immediately what came to my mind was this image that I'm showing here, which is an image of the Carnegie, which, you know, it's not exactly Sagres, our sailing ship, but it's quite close. It made the connection. And this ship actually it was a ship mostly made of wood, no iron, and it was devised to study the magnetic field. As very often happens in science, you know, sometimes you want to study A and you discover B. Actually, the Carnegie is most famous probably not because of the magnetic field, but because of the electric field. He measured the Earth's electric field, and the measurements of the Carnegie had some kind of surprising effect, which is the maximum of the electrical field along the day was always at the same hour, irrespective of the place. If you measure most of meteorological variables like temperature, you expect the maximum to be at the local midday. So the maximum in Cape Town is not the same as at the same hour as the maximum in London. So because it has a local, it depends on local time and local effects. But actually the electric field, if you measure it anywhere on Earth, you'll see that that maximum is at about 19. And that was kind of a surprising, and that was it's a very big discovery of the Carnegie. And you believe it or not, this is still the curve, this measurement made by this ship 100 years ago, that we still use as a reference of what is the global electric field. So it's extremely important, and I'll try to give you a little bit more of detail on that. So why this kind of show us that the electric field is a global signal? It's like we are seeing a heartbeat of the planet. Because we understand why this happens. If you look at the plot of the discharge, I know this is a bit busy. So on the horizontal, you have the time of the day, and on the vertical, we have the number of flashes of discharges, lightning per second. And what we see is not surprising. We know that most of lightning occurs in Africa and South America, very little over the ocean, most over land. But you see that the world, say, the overall lightning as a maximum at 19 UTC. So the Carnegie curve, the electrical field, was really reflecting this global distribution of lightning. And it's something that is very difficult to measure actually on land. So now we know that there is a global electric circuit, and you kind of understand, again, this is perhaps a little busy figure, but gives an idea of this all the interaction of space and earth components that needs to be taken into account to understand the electrical field. We now know that you have a positive ionosphere, a negative earth surface, so we have a potential difference between the two. We know that the ionosphere is heavily influenced by the particles that come from the sun, at the gamma rays, cosmic rays that come from near space. Of course, it depends a lot on the state of our electromagnetic field, whether it deflects more or less particles coming in. And we never, it's like a person. We cannot probably assess the health of a person just looking at one organ. It's the same, of course, with the Earth system. Everything is connected. And the electric field is really one of those things that you really need to take into account: near space, sun, the ionosphere, atmosphere up to the surface. You cannot really, so what's the project really goes into space-Earth interactions. So we know that we have this difference potential, the ionosphere is positively charged, but what keeps this going on is actually the thunderstorms that occur over the planet. So at every time there's about 1,000 of thunderstorms occurring at every moment on the planet. And this is global, say, cumulative, that really creates this current. So whenever even if we don't have any lightning, if it's fair weather, we still have an electric field on Earth. Of course, this current really depends not only on the potential difference between the 2 points, but on the medium between of the conductivity of the medium. And that is, of course, not very easy because it depends on how many charges, how many charge carriers, ions do you have in between. And that is actually affected by what happens above and what happens below. So I'm just going to give a very brief idea of what is involved in atmospheric ionization, so the creation of ions. We know that when we have cosmic radiation, solar radiation, they interact with the gas molecules in the atmosphere. It creates ions. And we know that ions also tend to promote the nucleation of formation of aerosols. So we have this influence from above. And then we have an influence from the surface. So on every land surface, you have radionuclides that come from formation of the planet, potassium, uranium, thorium, and they are always releasing radiation, gamma rays mainly, and radon gas. And these also contribute to, this is ionizing radiation, also creates ions in the lower atmosphere. And every time we have at least these two processes occurring. Of course, when we are very high in the atmosphere, the space component the radiation, cosmic radiation dominates. When you are closer to the surface, the environmental, the ambient radioactivity from the land surface dominates. But we have a mixture of both. The advantage is that when you are over the ocean, you kind of get rid of this component. And that's why I was saying that it's kind of easier to measure over the ocean, because if you measure the electric field over the ocean, we kind of get rid of this contribution, or at least we reduce it substantially. So the Carnegie really made this very big contribution of showing us the global nature of the global electric circuit. But you can think of this as really very nice, but why do you want to do it now? So why do we need to measure the electric field in 2020? And of course, just let me say that it is surprising. For me, it's still surprising. But since the Carnegie, this is the data that we have. There were some measurements over the Atlantic, some over the Pacific. But since the Carnegie cruises, we never had actually some global measurements of the electric field. So that was kind of a compelling, also timely reason for wanting to do this. But we have some also very strong scientific motivation. One of them is that the atmosphere, the planet has changed since 100 years ago. And that we know that in the climate change context, we'll have more convection, eventually more lightning. Of course, the model is still not exactly 100%, but we understand that there should be changes that would affect the electrical properties of the atmosphere, and these should be measured. And another reason, again, is related to aerosols. If you have more pollution, we have different distribution particles, aerosols, they should affect the conductivity. They should affect this layer that really affects the currents and the global circuit. So this is, say, a very strong scientific motivation for doing this, for the SAIL project. I just like to say that science is not done by computers or by instruments, not even by a beautiful ship. Science is done by persons. And actually, we are very, very lucky to have not only a beautiful ship, a wonderful ship, but also a wonderful commandment. And it's very curious because the commander of the Carnegie, of several cruises of the Carnegie old, is still very remembered as a font cap. It was not only captain of the ship, a magnetic observer, and it's very interesting to look at the history of Captain Old. And we also have Commandant Mauricio Camilo, who actually not only was very keen on the project, very keen on having science on board, but also had the vision and also the scientific background and interest that actually made that possible, because only a ship would not do it. You need people. So let me just do a brief overview of the SAIL project. So you can follow all developments on Twitter. We try to put everything there. So we knew our focus would be the main boundary layer and the electric field in particular. So we decided, of course, that we need to measure the electric field, but as much parameters as possible, because this cannot be isolated from space component, from surface component, as many interesting, relevant parameters as possible. So of course, we measured ions, radiation, cosmic radiation, gamma radiation, solar radiations. And this was mainly INESC TEC and the Navy that have been doing this kind of space atmosphere component. Then we had, of course, an ocean component. We cannot forget the surface, and the surface is the ocean. And actually here we have two different aspects. One is the physical parameters, so the physical oceanography, which INESCTEC also and the Navy were responsible for that. And then we have a component of, say, biohealth oceans. And this is where our partners from CIMAR and from the University of Miami. And a very important component of the project, because I think the Sagres has always is of course a Navy ship, so it has its military, its Navy missions, but it's also a very special ship as for diplomatic reasons. So it's very emblematic. It's something that appeals for the people. So we wanted really to make a very strong dissemination, taking advantage that this is something that can catch the imagination of people, of young people, and of the scientific importance of the trip and of these space, atmosphere, ocean interactions. And here we have a very, very important contribution of a center that actually took head of the dissemination and the workshops. One very important aspect of this project is that it's not even inter or multidisciplinary. We really wanted to have heavily transdisciplinary and very, very keen on open science. So we have all our codes, management plans, everything is public, it's open, it's on Zenodo, and we really want to promote transparency because our ultimate goal is for the data to be useful for the scientific community. So I'm really putting a lot of effort in making everything as clear and open, as transparent as possible. So this is in a nutshell the SAIL project. And just to give a very short introduction of these two components, of these three components. So in terms of the space atmosphere monitoring, we have two electric fields, two field mills measuring the atmospheric electric field, one on the top mass and one on the lower parts at different heights. We have a gamma radiation sensor. We had cosmic radiation, which unfortunately it was the only sensor that didn't work. We put it there, but we had issues with the cosmic radiation, but we still have gamma. We had an ion counter here, a visibility sensor, solar radiation, and we also installed a kinematic. Of course, the ship has a GNSS system, but we really didn't want to have any kind of interference with the Navy's systems. So we had our own GNSS system for also spatial and temporal reference of the sensors, and also to try to infer the attitude of the ship. So it was a kinematic GNSS system. And for controlling all of this data, most of the data were measured 1 second. I think GNSS 10 hertz. We had a software tool, the SAIL tool, that was developed to organize all the data, to transmit all the data, and to store it on board. So the ocean component has actually, so the ocean monitoring had these two aspects, the physical and the biological. For the physical, we actually at INESC TEC developed a towfish, and this towfish was, so we had inside a CTD measurements for pH, dissolved oxygen, chlorophyll, spectral radiance. So this was a prototype sensor from the University of Minho that we integrated in our towfish. No, sorry, the acoustic noise is from the University of Minho, spectral radiance is from INESC TEC also. And we integrated these in this towfish that was actually towed by Sagres. So one of the issues was the cable and all the structure that had to be developed to be sustained by such a big ship. So this was actually a very, I think, very nice work of engineering by that did that. And then we have this aspect of having fish samples. We didn't catch fish on purpose for the project, but since the crew would typically fish occasionally, so when the idea was to use these fish that were occasionally caught and to take samples of them and for them to be preserved for further analysis. And that was so the colleagues at CIMAR made a very nice box, field box, with the tools, with all the materials. Actually, the captain of the Sagres did a course at CIMAR to learn how to do the sampling and preserve. So it was a very interesting cooperation work. And so we get so when there was a catch, to take care of what was the species, the weight, the length, and then the samples of parts of the fish, the gonads, the gills, the fins were preserved, frozen for further analysis. So it has also these components. And finally, the dissemination component. So Edge Center did so I met Tania in Cape Verde. We had 3 workshops. So one in Tenerife about marine robotics, one in Cape Verde about biodiversity, and then in Rio de Janeiro about meteorological ocean numerical modeling. And I think, of course, these were not very big events because there's not much space on the ship to have accommodate a lot of people. But it was really interesting, and their center really, Moutinho really could convince all people to get to us, and I think it was a very interesting aspect. because we could mix people from different backgrounds, different areas. Of course, we started to plan the workshop for Cape Town, but unfortunately we could not do it. So what is the status now? This is the map of what was planned for the circumnavigation here. So, but indeed what we actually did was, we had to return from Cape Town again to Lisbon due to COVID-19 restrictions. So we only did a small part of the trip. The good thing is that measurements actually continue. So although the ship is now docked in Lisboa, and you can see as a photo, actually we took advantage of being docked to do some calibration and validation work. But we have all the sensors there, all the instruments continue to measure. So although this is not an ocean measurement, is still a coastal data set, but I think it will be very interesting. I think what we did so far, it was very successful because we have measure all sensors work except for cosmic radiation, but we do hope to have it again. We have 1 second data from all sensors all along these 5 months that's doing the navigation all over the Atlantic, North Atlantic and South Atlantic. This is about 10 gigabytes a day. And we've been very busy looking into that, organizing, processing the data. So it's kind of, the goal is in the near future to have them at the INESC TEC Research Data Repository. And of course, we want these, as everything else from the project, to be open and to be as much as is by the community as possible. And let me just not only thank you for attending, but just thanking this amazing engineering team, also known as Smurfs, because we always wear this blue. But of course, this project, without this engineering team led by Edward Silva, I don't know, it would not really been possible to do this work, which was really very challenging because most of the preparations were done in 3 months. So I'm very proud to have the chance to work with this team. So thank you.
Thank you, Susana. Thank you, Susana, for a really interesting talk. And it's great to see the project continuing despite COVID. So I'm going to ask a couple of questions first, and to allow people to write in the Q&A questions chat. So following these last few slides that you presented, what was your biggest challenge in the sail campaign while on board Sagres?
I would say that the onboard part was the best and the easiest. Actually, we had always, during all the trip, we had someone from INESCTEC on board all the time. I had the privilege to be from Cape Verde to Rio de Janeiro, so it was really a memorable experience. I think that every scientist should do some field work, particularly at sea, if we study the sea and the atmosphere. And I also learned a lot from the officers because they know the weather in a different way. They know it better in some aspects. So it was really a nice experience. The most challenging was really the preparation, which was really 3 months, very, very hard. And of course, we had constraints because this is not a research vessel. This is a Navy ship. And the idea was to try to accommodate as much science as possible without disturbing, of course, the main mission of the ship. So we had constraints in terms of cables, power, energy, places to put the sensors, and the time constraint, 3 months. And actually, most of it was done without explicit funding. So it was a lot of goodwill. All the partners tried to contribute somehow in kind. We didn't have a lot of money, but everybody understood that this was kind of an opportunity. It was a unique shot. The ship will depart and either we'll do it or not. The administration of INESCTEC was very supportive. So as I told in the beginning, this was really the outcome of course, very hard work from our engineers and a lot of helpful people that really made, but it was hard. That was the hard part. Being on board is wonderful.
Nice, good to hear. And it's great to see that when it's needed, there's really a lot of collaboration and a lot of goodwill from researchers in science. So it's great to see that. I have a few other questions. One is asking you to tell us about the story about a jellyfish and the toadfish.
Well, I was not on board when that happened. So it's a second person account. But the story is that we had this wonderful towfish that was really, again, this was a piece of engineering made in a very, very short time and a very hard work. And it worked wonderfully, except some jellyfish or very big jellyfish somehow felt attracted by it. And so when we got the toadfish out of the water, it was completely, I think, rolled in jellyfish, and it did some trouble that were corrected afterwards. But yes, so there's a story. I'm not good at telling it because I was not there to witness it. But yes, there's a story about it.
There's always these interesting, funny stories. So we have one question from Nigeria and probably links to a graph in your presentation showing more flashes in Africa. So the question is, why is there so much lightning in Africa?
Uh, that's very easy. We know that most of the lightning discharges occur over land and occur in the tropical region, so where you have more thunderstorms. And occurs over land because you have more contracts between the convection is promoted by the contracts between the temperature of the surface and the air temperature. So when the day goes down, the earth is still warm and the air cools faster, basically. So if you look into a map and you see the equatorial area, where is land is Africa. So lightning tends to occur in the tropics and over land. So you do get a lot of lightning, or most of the lightning in Africa. Of course, it's interesting that I think the country with most damage by lightning is it's not in Africa, it's Brazil. And I think the second one, if I'm not mistaken, is India. And that is because the fatalities really have to do with the density of people, and that people that are in the fields that are outside exposed to lightning. So although the occurrence is larger in Africa, the fatalities or the risk for people, still a lot of people die by lightning. It's amazing. It's still in Brazil.
Mhm. And actually, you just answered one of the questions, which was why is Brazil number one in death related to lightnings?
So
Yeah. So do you think that Sagres will continue the voyage after the pandemic is over?
no one knows. Actually, at this moment, no one knows. I think the celebrations of the circumnavigation were supposed to take place from 2019 to 2022. So we still have that time window, still in time for the celebrations of the first circumnavigation. Of course, this has to do with the decisions by the Navy. From our side, the ship is ready. So whenever it departs, we'll do the measurements. For example, there was a small trip. I was very lucky to return to Sagres in September for only 1 week because the ship made a small trip around the Portuguese coast. And of course, we did measurements. So the ship, whenever the ship sails, we'll be doing the measurements. So the system is operational, and that's we don't know. We expect the ship to make some big trip sometime in the future, but no one knows when the pandemic will allow us to do that.
Well, let's hope that be over soon. Um, do you know if there's a way for recent graduates or young scientists to be involved in this research?
Yes. Uh, let me say, if I say we are very keen on having young graduates and scientists involved in this research, then there has to be a match between what we can fund, which is not much, and also, for example, it's very difficult for us to find PhD students, which is something that I find quite surprising. Sometimes we have more senior persons, but it's more difficult to hire. But I think that again, when I believe that when there is will, you get a way to do it, right? So sail is really a very good example of when there is a will, we'll find. And I think we need to start doing it, and then you will find a way. So if someone is really wanting to be involved in the project, so welcome, and we'll find a way. But yes, actually, we do need a lot. We have a lot of data, and our goal is to have it as much widely analyzed as possible, because I think the data are very relevant, because even on land you don't have this kind of combination, electric field, ions, gamma radiation. It's not that common even on land, much less over the ocean. And this is a work that needs to be done by different teams from different perspectives. So people from aerosols who might see one way, people from ion side, people from radioactivity, from cosmic radiation. So we do need a lot of different skills to interact in the project. So far, the the emergency was on the monitoring, so more on the engineering to get the data. But we are moving towards now. Now we are very much into the data management. So making the data properly, all the metadata, all the properly stored, organized, processed. We've just published on the nodal the post-processing and the georeferencing based on GNSS of all the data as well. That's part, but then we'll come to really to the science based on the data, and we'll need very multidisciplinary skills. Yes.
Good. So if someone is interested, please contact Susana.
Yes.
Uh,
Yes.
I had this question, actually, or suggestion regarding to the continuation of the voyage, that you could also maybe perhaps, and now that we entered the UN Decade of the Ocean Sciences, maybe it would be good also to perhaps have a connection um, with, with the research and the Decade of Ocean Science.
Yes.
This,
Yes. And
um,
I'm not shown much data actually, because I was so afraid. I tend to speak a lot, so I was very much afraid to take it too long. But we have, for example, from the ocean, we had very nice measurements from our towfish. It didn't measure for long because we had an issue in South Africa, and the idea was always when we were planning that we'll have time to make replacements, but because of COVID, without traveling, so it became impossible. But we have, for example, even just the ocean component, just all the measurements that we did. I think they are relevant because they are not made on typical points where you typically sample. So this is kind of a ship of opportunity, but it's not, because it's a Navy ship, so it doesn't take the usual routes from the merchant ships. So we are actually sampling the ocean in areas that we typically don't do it. So we have oxygen measurements, chlorophyll measurements that I think are relevant in places where you typically don't have buoys, or you don't have these ships of opportunity, and also then in connection with the satellite data. So although we were very much focused in the atmosphere, because the towfish itself was a technological development itself. So when we have the chance, I think this is a very important component of the project.
mhm.
So yeah, I'm seeing the question about Earth observation. I use Earth observation in my research. So I did my PhD on sea level. So I use a lot of satellite altimetry data. Most of my PhD was based on satellite data. But we haven't started yet to analyze the cell data in connection to Earth observation data, because as I explained, we were on the monitoring stage. Now we are on the data management stage, and eventually we'll come to the to the combination with Earth observation data.
Okay. So we have said that you spoke of oceanographic measurements. These questions from Ana Maria Martins, and she asked what sort of measurements were made. Just surface or water column?
Um, I'm not sure if I can share my screen again.
Okay.
Can I do it?
Mhm.
So the device that, can you see the slide, Tania? So the device that we used, it's a towfish. So you have a cable, and we don't make measurements on the water column at depth. So it was about 5 meters or 10 meters, depending on the ship's speed. But we were thinking about doing that. But so kind of a towfish that would move up and down on the water column. But the measurements that we have so far are from near the surface. I'm not sure if that answers.
Yes, I think it did. So let's move on. So there's a question from Carlos from Brazil, and asks, can you share some early results of your data collection?
Yes, well, here in the presentation, actually, I don't have much, it's true. So I'm just showing you here one of the results, which is not the Sagres curve in terms of the average curve. This is just one, but for me, it's one of the most important results. So this blue curve is actually 1 second measurements of the atmospheric electric field without any processing, averaging whatsoever. And when I saw this curve, so this is one of the most beautiful ones, I have to admit. So we have some strange ones also, of course, when we have lighting. But this for me is a very nice result, because when we started the project, one of my first concerns was if it would even be possible to measure the atmospheric electric field, in the sense that we are not in a ship as Carnegie, that it was made for magnetics with no iron. We are on an iron ship with all kinds of instruments, electronics, satellite systems, communication systems on board. So with a lot of electronic noise, say. And so it's true that sometimes in science, some things were easier to measure in the past than now, because now we do have these kinds of electronic noisy things that do not happen in the past. So I was really a bit scared. So when I had this idea of the electric field, so let's measure the electric field. I didn't expect, my boss was very enthusiastic. The ship captains was very enthusiastic. And then I started to be very scared, because I said, well, I'm not sure we can do it. And I started to speak with engineers, the people that made the sensors, my colleagues that are expert on the electric field said, I don't know, can we measure it? And actually said, yes, you should try, go ahead. But I was not very confident. So when we saw this curve, which is really a very nice, Carnegie-like curve, so really representing most of the global signal rather than these local contributions because of local ionizing sources. Then that's really show us that we could measure it, and it could measure it very high quality, because these Carnegie curves comes from averages from several measurements, several places, several cruises. And in just one day, we could recover a very beautiful signal of the global electric circuit. So that's why I think this is one of the most important results of the project, taking into account that we really want to study the electric field and this global circuit component without having the effects on land. I really don't have here plots of the ocean data, because we didn't start to explore them. We had some plots per day of all the variables just to check if the sensors are measuring correctly, but we really didn't start any analysis. And we also have, actually, I didn't put it because I thought it would be too much. It was my mistake. We had very nice results in terms of gamma radiation, where we really see a very nice contrast. It's not that we don't know, we know that the radiation over land is very small, because we don't have this surface contribution from radioactivity. But I didn't expect to have a very sharp transition. And it's really kind of sharp, really very abrupt. And I think that we could measure it for the first time. So we do have already some results, but this is this was 10, 15 gigabytes per day. So and we are really still handling the data. But I think in terms of scientific results, I would say this contrast land surface, um, land ocean in terms of gamma radiation was quite unexpected. Actually, I once made a movie. I joined all the plots of gamma radiation per day. And then I just showed to the officers in the ship, or just like after dinner, I just showed them like if it was a movie. And they had like the date on top. And it was very funny because the officers didn't know anything about gamma radiation. But they just looked at the plot and said, this we sail off. This is where on the ship. This is where on land. They could just see by gamma radiation, which was a very interesting result. But I could search, but not immediately.
Interesting, very interesting, Sana. Um, yeah, it's nice to see that they always try to put the people that are on the ship uh, involved with the science that was being conducted in on board.
Yes, it was amazing because we were actually, I felt part of the crew.
Yeah.
And the second time now in September, we also had, there were some guests and I was very proud that when someone said, Susana is already from the crew. So I was not treated as special as a guest because I was treated as a guest, of course. I was not from the Navy and I'm not from the Navy. But I think that, and I think that it's very important in science. There's a lot of knowledge that it's not, say, scientifically formal knowledge, but it's knowledge that needs to be taken into account. And
Mm-hmm.
I find that in very different situations, but in this because these people are trained to be at sea. So when you write a paper, if its paper is not okay, that's not a big problem. If you are at the sea and your predictions are not okay, or if you don't go to the right place, that might be a problem. So it's a different type of knowledge, and I do value that knowledge a lot.
Mm-hmm.
And I think it's very interesting to try to incorporate and to merge and to add, to complement. So the scientific knowledge with this cement knowledge. And
Mm-hmm.
also the thing is that I think it's very good when people are enthusiastic about science. So we learn about our science when we want to explain. And actually, I think that in the beginning, except for the commander, which was always is a scientist, so was very keen, was kind of some suspicion, these guys around, civilians around the ship doing, and and I think that in the end it was just the the whole crew was very enthusiastic of sail, and I think that incorporating this knowledge and disseminating and merging this military and civilian and scientific, non-scientific knowledge, and as I told, I think SAIL is a combination of will, a goodwill for the common good, and the common good was for the project. And I think a lot of people work. We had our engineers on the mast 20 meters above until night. So it was night. You could not see. I said, please go down. And they were putting cables. And so that was really, it's a project of love, of
Yeah.
goodwill.
And I think it's very exciting when people feel that they are contributing to to the project or to the campaign or to the science or any
Yes.
other.
So we also have the obligation to make the data available. We try to make even the insights, so the code, the way we did things, to be replicable. Because if you look into the Carnegie 100 years ago, there's a book on the cruises. And it's amazing what he did. Because nowadays, we could take the original data, could go to digitize the data, and it fits. So they did. I'm not sure if today we have this ability to document things as they did before. Sometimes I wonder, with computers we have a lot more, but if you look into the Carnegie records and the way this detailed work that was done during several years, doing measurements and then collecting and analyzing. So it's really something that I think we modern scientists could learn from, And my wish would be that the sail data, someone 100 years afterwards could look at least into the data, replicate the analysis, replicate the plots. And I think the Carnegie is really a very big inspiration because they did it right. And sometimes I'm not sure if with all this technology, we can actually do it as right.
Interesting. Well, hope so. So okay, so very very good. We have here two questions that are related to aerosols. So the first one, it's how aerosols from ships can impact very high clouds, such as the ones you showed in your presentation. This is the first question.
How they can impact.
Very
So
yes. So yeah.
So I'm not an expert on that. Actually, I'm not an expert on anything. I know a little bit of many things, but I will try to explain. I think that the way the aerosols affect, they actually affect the nucleation process. It's a bit related why when you want to put some seeds to make rain. So if you have particles, you help the formation, the coalescence of droplets to form. You affect the cloud microfixes and the formation of these cloud condensation nuclei. So the aerosols, I'm not. I think that of course the aerosol experts will explain it much better. But my understanding is that it's an area where we still also don't have we have a lot of knowledge, but the quantification is still a bit hard. But these shape tracks that I show, it's just a visual way of seeing that the exhaust, the aerosols from the exhaust do create is right. It's not, these do affect somehow the clouds. Now, how they affect drops or the cloud formation, exactly that is another process because it also depends on what type of, again, the electricity are these aerosols charged? What types of charge? What type of the size? The size distribution. So the process itself is complex, but we don't have any doubt that they affect strongly the cloud. Not only the way clouds form, the droplets, if it will be clouds that will give rain or not, so that for sure.
Okay. So also related to, well, aerosols, and these questions from João Lorenzetti from
About
INPE.
wave breaking, yes, that makes sense. So actually, one of the reasons to have the sensors at different heights, that was not my idea. Actually, it was a colleague of mine that suggested me. I said, because, I'm not an expert on the electric field. So I just, had this Sagres idea, I wanted to do this. Of course, I went to colleagues, said, I want to measure on a ship. And then I asked for suggestions and help. And one of the suggestions was exactly this because of the salt that will also not always wave breaking, but the salt will certainly make an influence on the electric field. So that's why we have two sensors at different heights. And from what we could see, the results are quite consistent between the two of them, but it's certainly something that we'll have to take into account for sure, the wave breaking. About the artists, I don't think we have. I would say that um, from my understanding, there was a lot of opening from the ship and the commander of the ship to have all kinds of science and the collaboration with science and the civil part. So I think it's certainly an interesting idea, but it's not. I don't know. It would be interesting to put that idea forward and see. I don't think they have an artist, but I know they have many people sail, journalists and with very different backgrounds, not only scientists.
Yeah, like you said, I think they opened a call for people if they were interested in joining the campaign, right? So yeah, if you are an artist, be keep your eye on the Sagres voyage, and maybe there's opportunities for it. Um, and so there's a question from Ibrahim from Nigeria, and he asks, how do you relate your research to climate change? Should we expect more, less, stronger, weaker lightnings?
Um, I'm very wise. I never make predictions. I never make predictions. Um, this observation, this research is certainly related and relevant for climate change. But I think the issue is quite complex. So my aim is a little bit more modest, and that is this observation and the knowledge that could be generated could contribute to improve the models that we know they need a lot of improvement. That could contribute to understand processes that are difficult to model, like this cloud microphysics, the way the electric field interacts and interacts with the clouds. So, but it's like a long way. It's not like Sagres climate change immediately. It's not a straightforward link. What we seems to have, what we seem like a common knowledge is that if you have a warmer planet, you have more energy on the system. So somehow you have stronger convection, stronger thunderstorms or more thunderstorms. And this seems to the studies that we have so far seem to suggest that you have a more turbulent planet, so eventually more lightning. And actually, I think, I don't know if it was 1 or 2 years ago that was observed some lightning even very up north. I don't know, not in the Arctic, but very, not in the North Pole, but at very high latitude, which is kind of very unusual because, as I said, most of lightning occurs over land and in the tropics. So we do expect that climate change, it's not kind of common sense that the climate will change and the global electric circuit that depends so much on so many different components will remain the same. So we know that the electrical properties of the atmosphere, which influence quite a lot, eventually even biology, because we all developed in a planet with an electric field, which I have to say that before being involved in this kind of research, it was something that I never thought about it. But the same way we have this, the eyes we have because we are in this kind of star with this radiation, so our eyes are adapted to see to our light from our star. Our bodies are evolved in a planet with an electric field. So still a very active area of research, a very difficult one, this interaction between biology and the atmospheric electric field. But it seems reasonable that all organisms evolved in a planet with an electric field, with some these kind of electrical properties. And if you change climate, you also change the atmospheric, the electrical properties. Um, so the models do seem to suggest an increase in lightning associated with climate change, but with, as everything in models, is that the devil is in the details. So I can very broadly say climate change, more convection, more lightning, but then when you go into the details and really quantifying, there's still a lot of things that we don't know. So that's why I think it's very important to have detailed studies and really in situ observations, not only satellites, which is extremely important, but really measure as much as possible. Because one thing is modeling, I love models. The other thing is the measurements, and we should have as much as possible. So I'm really not giving you a very straight answer on climate change, but I don't have one.
But I think you're giving really a clear feeling that there's oh, there's never an easy answer, and everything depends on everything, and it's way more complex than what we think. So yeah, thank you. So we are out of time, and thank you everyone. Thank you, Susana, for a super interesting Q&A session. Um, but before we close the session, Susana, would you like to give any final remarks?
Thank you. Thank you to all. I'm extremely grateful for all the work not me, for all the work, as I told, all the people, from the ones who designed the logo of SAIL to the people working on communication, to the engineers, all these work, and we have a very big responsibility to deliver now in terms of results and data, and it's very rewarding to do that and to work in this kind of positive environment.
Yes, thank you. Thank you, Susana, for sharing this. So, and remember, if you want to keep updated with everyone, if you want to keep updated with news from Sail Project, please don't forget to follow on Twitter. So thank you, Susana. Thank you, everyone, for listening, and see you next Friday. Next Friday, we will have a thematic special session on nanosatellites with experts from Europe, Africa, South and North America. So don't miss it. Okay, well, thank you and bye-bye.